So we are asked to find the area of this outside area, which is inside the larger circle, but not inside the smaller circle. So we need some information about, first of all, we need some information about lengths for sure, because this is a value question. We're asked for the area. We need to nail that value. There's only one value that would get us a sufficient answer. And in both statements, if we look at them, we get values which we could use to get some information about area. So let's look at statement 1 first. Statement 1 says AB is 3. And A to B is the distance from the outside edge of both circles to the center of the smaller circle. And this tells us that the area of the smaller circle is pi r squared. So it's pi 3 squared. So we can definitely get the area of the smaller circle. Now, can we get the area of the larger circle? We know that BC is equal to 2. Well, C is the center of the larger circle. And so if we know the distance from here to here is 2, we know the full distance from the edge to the center of the larger circle is a total of 5, 3 plus 2. And that means we can definitely solve the area of the larger circle. And that makes this sufficient as an answer. So statement 2 on its own, what does it give us? It says that CD equals 1. So if we look at CD, C to D is from the center of the larger circle to the edge of the smaller circle. And if that equals 1, that's not very helpful. But then we find out that D to E equals 4. And what this tells us is the distance from the center of the larger circle to the edge of the outside is a distance of 5 rather, a total of 1 and 4. And that means that we can solve the area of the larger circle. Now, can we get the area of the smaller circle? Well, we know from the edge of the larger circle to the center. So from the edge of the larger circle to the center of the larger circle is a distance of 5. And that means that the distance from, let's grab another color, the distance from here to here must also be 5, because that's from the center of the circle to the other side of the larger circle. Now, if we know the distance from there to there is 5, and we know that that is almost all the way across the smaller circle, except for the distance from C to the middle, to the edge of that circle, which we know is a distance of 1, then we know from here to here, this pink color I just drew is a total of 5. From C to D right here is a distance of 1 for a total distance across the smaller circle of 6, which means the radius is again 3, which means we can solve the area of the smaller circle as well. And now that we have both areas from statement 2, this is proving to be sufficient as well. So knowing this first piece of information didn't seem very helpful at first, but you have to try to construct as much information as you can using the rules of geometry. Leverage information that you know about radius and area, and try to piece together additional information beyond what they're simply telling you by using the rules that you're familiar with. So here our answer choice is D. Both statements alone are sufficient.